we are going to introduce some of the material. The material which we're going to cover is based on next unit. It's Unit 4, Module 1, Class Design. Now, what you will note from this is a continuation, but where we left off earlier, we did use case design this. Now we're going to look at the actual classes. What do we need to look at in classes? Analysis and early design, we discovered a number of classes. What is the things that we need to identify in class design when designing a system? Boundary is a type of class. Okay, keep in mind that we're now going to start to look at the attributes. The operations. So when we're doing this, we're going to now start to look at the actual implementation, because we're going a lot closer to the implementation. So from this, is quickly going to mention that what is used to do this. But the purpose of this is to ensure that the classes provide the behavior, the use case, and realization require. Okay, so ultimately we're going to look at our class and look tricky, but is the operation there? Can it do what is required? Is the attributes there? Okay. Then, to ensure that sufficient information is provided to ultimately go and implement the class, looking at the methods. Is there enough information that so that someone can sit and write the code for it? Okay. So to possibly handle non-functional requirements and to incorporate your design mechanisms. So in order to do class design, there is all the steps. Yeah. Okay. You'll see it's going to look at creating your initial design classes. Defining the operations, method, states, attribute. Dependencies, association, generalization. Resolving use case coalition, handling the non-functional requirements in general, and then lastly there's a few checkpoints. Okay, for now we are going to look at the first ones up to the attributes. Now, as I mentioned there, to identify the initial design elements, and we've done some of that. We've used our analysis, class stereotypes, and we've expanded them. We've identified some classes for them. But we might now go look at some applicable design patterns to expand this even more, to possibly add classes based on this, based on the patterns. So we might need to look at how many classes is really needed to do this work. I'm going to create one class that is so fat that contains all the work and operations for you to do this, or are you going to split the work a bit? Okay, what they're saying to us, it's rather better to have a class should have a single well-focused purpose, and that class should do one thing and do it well. Okay, what does it mean? It means that we might get to the place of actually defining multiple classes, where each class has its own purpose and own role, what it's going to fulfill. So we might get to the place of not working with only a few classes, but rather more classes in our system. Okay, so one of the things that we might also be looking at is looking at the translation from your boundary elements. We have done that so far. Then looking at the strategies for designing entity classes. We're not really working with so much data, so you might get to a place of deciding, are you splitting them? Are you going to create a parent-child situation? That is things that might need to consider. Okay, but then what you need to also look at is, for example, your control class. What is happening here? Do you really need it? Might you need to split it? Is there so much work which it's doing that you might split it in multiple classes? Okay. So what is some of the things that we need to look at when deciding on this is the complexity of the class. Is it really complex or is it simple? What is the probability of change? How often is it going to change? Is it ever going to change? This distribution and performance and transaction management is two other ones that we need to look at. Then there's a mention of design patterns and mechanisms, where they're saying to us we're really incorporating a pattern and or mechanism is effectively performing many of the subsequent steps as part of this. What is a pattern? Who knows what is a pattern? There is a section what they say a pattern is defined as it's a solution that refers to the answer to the problem in context that helps to resolve the issues. So ultimately what we're seeing is we might see that we have the same problem over and over in the system. How are you going to solve that problem? Are you going to, every time that you get to the problem, need to solve it again and again? No, you might go and look at actually existing patterns and apply that and use it appropriately in your system. Okay. So where do we see patterns in real life? In a refrigerator. How do we see it in a refrigerator? What about the temperature? Okay. Let me firstly give you an example of a pattern. You've seen, you see these desks in front of you where you're sitting. Okay? Was a pattern used to make these desks? What is a pattern? Some form of a blueprint. If you look at these holes where these desks was cut out, was some form of pattern used there? Did the person go and measure it and every time apply the same principles to get that there? To some extent, yes. If we look at the ladies who's studying fashion design, okay, and gents also these days, okay, but who's studying fashion design and making clothes, what do they use to make our clothes? Do they just put the fabric over the person and then just cut it? And then what happens if it's two sizes too small or too big? They measure again. My sister is a fashion designer by study, but not by trade anymore. But one of the subjects was pattern design, where they actually go and they make patterns. And then they will cut it out and put it on it. But what is the principle of it? So that you have a solution and that you can reapply it. Okay. Because that piece of fabric or piece of paper can be used again and again. Okay. So even when we're designing a system, we might get to the place of having that same problem and we might need to apply it again and again to solve it. Okay. So there's quickly a mention of some of the embedded system design patterns that we might look at. Okay, so there is one for half calling of half call. It helps to simplify the system which support interworking of multiple protocols. So because it's embedded systems, what are we seeing? We're seeing multiple protocols sometimes used in the communication. It's not just serial communication. Okay, but now it'll be a matter of how are we communicating. Okay, there might be a message factory and message interface. There's a publish, subscribe pattern, hardware device. Okay, so there's a number of patterns which can be applied. We're not going to go into the full details of this. There's a number of books written on. Okay, so next we need to look at the actual operations and then go and define the operations. Where do we find the operations? Okay, so what they're saying to us, if we look at our sequence diagrams, these messages which we see here, what do they represent? Ultimately, it's going to become operations. Okay. So other things that we might need to consider is some manager functions, need of class copies, all of those. Okay. So then they're saying to us, Bird, we need to study the responsibilities of each of our corresponding analysis classes, then go and create operations for each of them. And then we might add some description to this. We might add more information to this. Okay. So if you go and look at your initial sequence diagram, or your design sequence diagram, what are you going to do? You're going to take those messages, and that means that there's going to be a operation in your class diagram. Okay, so when we're naming and defining these operations, we must go and look at how they are named. Meaning that we need to indicate the outcome, the client perspective, and be consistent among our classes to the approach at which we use to name the operations. Okay. So what does it mean to indicate the outcome? Okay, indicating the outcome means that it's going to show us clearly from the naming what is going to be the result of this operation. Okay, look a bit now. Then there's also on defining the operation signature. Operation signature means that we are looking at how this whole message is written. And from what we're seeing here, there's the operation name. But then we can be any number of parameters in the brackets. We can have the direction. Is it going to be an input, output, or is it bidirectional? What are we seeing? Then the name of the parameter. Then we can also see the data type of the parameter, but we're also seeing the returning data type. In a lot of your operations you're working with, and functions you might be working with programming, you're seeing integer or void. Okay. Now, that can indicate to us also your return type. Okay. So there is quickly a discussion also about indicating the outcome and then also the client perspective. Okay. So there's some of the things that we might need to consider when we looking at the operations. If we are passing the values by reference or by value, what is the difference? In the one, you're actually passing the memory reference to the actual value, and the other one, you are passing the actual value to be changed. Okay, so this has an impact on the speed and the changing of data. Is there going to be changes in the operation of our parameters? Are we seeing changes to the data? Is there any of our parameters which is optional? Default values also. So when we're doing this, we also need to consider the actual implementation language. Okay. If we look at C++, what data types do we see? Integer, char, float, bool, double. So those are some of the data types that we need to look at when we are defining our operation signature. So that when we're looking at our parameters, the data type and all of that, we're using the actual language which will be used. Okay. So the next thing that you need to look at is the operations visibility. Is it going to be public, meaning that it will be visible to everything, or is it protected and or private operations? Do you actually have protected in C++? I think you have private and public, but I'm not sure about the protected one. So then they're quickly indicating to us the difference in the denotation of in our diagram. Private is just a dash, public is a plus sign, and protected is a hash sign, denoting it quickly to us. Okay, so what we might also see is the scope of it. If it's determined, it determines the number of instances of the attributes and operations. So how many objects can we create from it? That might be a limitation that we need to look at. Okay. So what we're seeing here is that has now been applied, and they're giving us an example where we have a student, they have the name, address, student ID, and we have these attributes of private, then we have public ones. Okay. So there's a bigger example where they've indicated a bit more attributes. Okay. So the next thing that you might need to look at is to actually go and look and define the method. What is the difference between a method and an operation? It is like a pattern. Okay. Not totally. Well, not in this case. Okay. A method might be how you are cutting something or doing something. But we are now looking at, in this case, it is going to describe the actual operations implementation. What are we seeing with an operation? Operation in the sequence diagram was just that message. But if we look at our class diagram, what did we see? Yeah. These were operations. But when do they become a method? Method is what we're seeing when we're actually writing the program. Because method also now contains the body. If we had a method, if we had a operation signature, which was just like add schedule, it took some parameters, all of it. When we're going back, yeah, this is becoming the method, because it is going to contain some body here. It is going to contain some code where you tell it to actually now go and take the parameter and add it to something, do some work for you. Okay. So the purpose of this is to go and define special aspects of your operation for implementation, to look at special things that might need to be addressed. And these things are what algorithms is going to use. Is there a special algorithm that we need to use? Okay. If we look at an elevator, is that thing always going to go up? Let's say someone decided it's going up. What happens now if someone wants to go down? Is there a special algorithm that's going to address it? Okay. Is there other objects and operations that needs to be used? Okay. How is the attributes and parameters to be used and to be implemented? Is the relationships that are to be implemented? So those are some of the things that we might need to consider when defining the methods. So then there's the section where we need to look at the states. Our last semester we looked a bit at state. What is the state of something? In here I had water. Currently it's liquid. It's a very warm day. Okay, but is state important for a system? Because we might need to look at the state which an object is residing at. Okay. Let's take, for example, that elevator we have. Is it important to model the state of the elevator? Why do you say yes? Yeah. So one of the things that for an elevator which we might see is that it can be moving. What else? Stationary. How's it going to get there? Where does it start? When we start an elevator, where does it start? Is it directly moving, or is it what is the initial state of the elevator? So the initial state is going to go to the stationary position. And then from the stationary, what is going to go make it move? Okay, so when the user requests the elevator, okay, what is going to make it go from moving to stationary again? Ah, so when we're getting there, when the floor is now being reached, so what we're seeing is that the state of this thing is important. It is not always just staying in a very closed one. But this is now just the matter of requesting the elevator. What about the place where someone now decided to select the floor? Okay. So if the elevator is stationary, it's standing still. Let's say it's on the second floor. And you now decide to go to the third floor. What is it going to do? Is it going to use the same one there, or is it going to be a different? It's going to be a different one. So we are seeing the floor has been selected. Okay. And then even there, what is it going to go make it go from moving to stationary again? So we're going to see these guys. The floor has been reached, but it's there again. Okay. So this is some of the things that we might need to consider that when modeling the state of the system. Okay, so we've in a bit covered some of that now. We need to look at the actual state, the transitioning. Might be important. We might need to look at the initial state and the final state. Is there a final state for an elevator? Yes. Final state, it says to us, indicates the object's end of life, optional. It may have more than one. Does the elevator ever stop, really? Why do you say no?
People are using the elevator within a range of time.
Okay, so people are using it within a range of time. Okay, but that time may differ. Okay, so if the elevator is stationary, did it ever stop really? Did it stop having the ability to request or to go somewhere? No, it's still there. So I'm also of the opinion almost that the elevator doesn't really reach a final stage, but it depends on how you model it. Okay. So some of the things that we might see is that we might see the minimum maximum number of things indicated. Okay. How many floors can be selected? Why only one? But now there's 5 people entering an elevator. Guys, go to an elevator a bit and check what happens if multiple people select the buttons and select different floors. Okay, so is it only going to happen once? What is the minimum and maximum? Can you only select it once? To make it move, you need to at least select it once. Okay, what would be the maximum? Okay, so where this is going is to seeing, because when we're looking at the state, we might need to take that back to an actual attribute. Because how do I know what is the maximum? When is it going from open or closed? When is it going to go from stationary to everything to reached? Okay, so there might be some attribute which we need to model and look at. Okay, so there is a bit what we're seeing is when we're assigning a professor to a course offering, he can be assigned or unassigned. He can be a professor where he's not assigned to a course, or he can be a professor which is assigned to a course. Okay, so that makes a difference on the state. Okay, so we can even have an event where we're adding a professor or a remove professor. So that helps us to see what is going to make us transition. So there's a method that we can identify the transitioning steps. If we look at our diagram here, which we created, what made it transition from stationary to moving? Request elevator. The floor has been reached. Those things made it transition from stationary to moving. Okay. What is the time? Okay. Guys, what you will see, the rest of this really introduces a bit of the actions and activities. There's to the end of this just a matter which introducing attributes and how do you identify them. Okay. From where can we identify attributes? Remember, we've done the noun extraction, the CRC code, the specification document. From all of our documentation, we can go and describe, examine the methods, the description, the state, any information the class itself needs to maintain. What does it talk about? The knowing portions of a class. If we look at the responsibilities and the CRC codes, when we do this, helps us to identify the attributes. Okay. So you'll see these again, similar to operations, that we can identify the visibility of a attributes. We're also indicating the type of attribute and possibly a default value associated to it. Okay. So here's an example of what we see. The attributes has been indicated and the data types have been given. There's even a default value for the student, for that ID. Okay. Any questions, guys?